Hi everyone. In this video, I'll show you how to solve word problems that involve distance, rate, and time. And here's an example. A train leaves the station heading east, traveling at a steady 75 miles per hour. 2 hours later, another train leaves the same station, also heading east on a parallel track at a steady 125 miles per hour. How far from the station will the second train catch up with the first? Okay, so a couple things we can do to start organizing the information. One thing I like to do is draw some kind of picture, and when I say picture, I mean very simple. So let me think about this. A train leaves the station heading east. Okay, well, put this dot here for a station, and heading east means going that way. And that train's traveling at 75 miles per hour, okay? So I'll put that there. And then, okay, 2 hours later, all right? Let's say I'm not sure what to do about that 2 hours later business, but I'll leave that aside for a second. Another train leaves the same station, also heading east. All right, and it's going 125 miles per hour. And then it says, how far from the station will the second train catch up with the first? All right, so the reason I've ended these at basically the same point is I'm interested in when will this train be catching up with the first train? And that is what we're really going to try to find out, is what's this D? How far will they have gone from the station when they're both at the same point? Now, another thing we can use to solve these problems is a formula that you'll probably see a lot of in your math life. Distance equals rate times time. And we have enough information to start putting some of this in a chart. So I'm going to label my column headings distance, rate, and time. So I don't know what that distance is, as we said. That's what we're trying to find out, but it's the same in both cases. So I'll just put D down for both trains. And then I know one train is going 75 miles per hour, the other is going 125 miles per hour. All right, now back to this question about 2 hours later. Now we have to account for that somehow because that time is a very important part of this whole thing. So let's call the time that the first train spends traveling T. So the second train won't be traveling for as long as the first train. We know it left 2 hours later. Another way to say that is it is traveling for 2 hours less. So we can say T minus 2. So once we have that information, we actually have these equations kind of automatically set up for us. So distance equals rate times time. Distance equals rate times time. So we can write out the two equations over here. Distance equals 75t, and distance equals 125, and then this time is t minus 2. Now, very important, please remember to keep that in parentheses. So these distances here, I mean, this quantity d is the same as this quantity d, right? Because we're saying these have traveled the same distance. So once we have these two equations, they're both equal to d, we can set this 75t equal to this 125 times the quantity t minus 2, because they're each equal to d. So we can write that 75t equals 125 times the quantity t minus 2. So now we have this equation, and it's got the variable t in it. So we want to simplify it as our next step. So on this side we have 75t, and then equals. Now here we're going to distribute this 125 over the quantity t minus 2, meaning we're just going to multiply it by each item in there. So we'll get 125t minus, and then 250, which comes from the 125 times that negative 2. So at this point, we can subtract 125t from both sides. So that cancels out there. And here, the difference between these two, well, that's going to be negative 50t, and that equals negative 250. Now we want to get t by itself. We'll divide both sides by negative 50. And these cancel and we get t equals 5. But we're not done yet, because recall, looking back at the original problem, it asks us how far from the station will those trains be when the second train catches up with the first. So we're almost to the point of being able to answer that. All we have to do is plug this result we got for t, this 5, meaning 5 hours, into one of the original equations. So I always like to go with the simplest equation, saves time. So we can rewrite, well, we'll just rewrite that equation we're choosing right there. D equals 75 times t. And now we'll substitute for the t. We're substituting the 5 we got down here. And we'll multiply that out, use a calculator is fine, and we get d equals 375 miles. So miles is the units, because we were talking about miles per hour. And so that is our final answer, and that is how to solve a distance, rate, and time problem.